So it occurs to me that I need to really kick this off by getting in the proper attire. So let me cover up my boring old dress shirt with a much better looking t-shirt here. How about that? I'll even pull the badge out. Now it's official. All right, see, I knew the picture was going to be there. You gotta be ready for the picture. All right, so the title of this talk is really Security Onion, SuriCata, and Taylor Swift. How many folks like Taylor Swift? We got some big Taylor Swift fans in the audience? Okay, how many folks hate Taylor Swift? How many folks are just, Okay, good news. This is the last Taylor Swift picture in this presentation. All right. Might not be the last cat picture, but, well, yeah, it's probably the last cat picture. We'll see. All right, so let's really talk about combining SuriCata and host data using Security Onion. So let's first talk about kind of the history of Security Onion. What is Security Onion? It's a free and open source platform. As Victor mentioned, I started working on it way back in 2008, way back in the dark ages. And it really came out of my frustration with a couple of problems, and we'll talk about that in just a minute. But what I ended up building was really a platform for intrusion detection. And as we all know, IDS alerts are great. They start your investigations, but very quickly we learn that we need to kind of move into this realm of NSM, network security monitoring, and really surrounding those IDS alerts with contextual data to help us piece those investigations together. And really, network visibility is really, really great, but we soon find out that we're now needing to move into the realm of ESM, enterprise security monitoring, to include data from endpoints as well. And this really aids us as we're doing incident response, as we're doing our threat hunting. So really, at the end of the day, we want to provide a free and open source platform to give folks the best of breed solutions for both network and endpoint visibility at the same time. So way back in 2008, I kind of saw this problem. And the problem was that the bad guys that are breaking into our networks, they had Backtrack Linux, now called Kali Linux, and so they had this nice, easy-to-use ISO image that had all of their favorite tools already compiled, already configured, already installed. Just point and shoot, and you're now popping shells on networks, right? And so when I looked at, okay, what do we as defenders have? Well, we didn't have anything like that. So what we wind up with is this fundamentally unjust equation, right? That the bad guys have such a significant advantage over us that they can just point and shoot, and they're now breaking into our network. In the meantime, we're busy compiling software and configuring software and trying to get these things working just so we can do the real job of detecting and responding to these adversaries. So I said, you know what, this is a fundamentally unjust situation. It's time to rebalance this equation. So let's build something that hopefully I can use and hopefully other defenders can use as well. Started building it in 2008. The first version came out in 2009, and it slowly but surely started gaining a little bit of traction. We were very small at first, but over the years, things improved and the community grew. In 2010, SuriCata came out. We integrated SuriCata, so we gave folks a choice of using either Snort or SuriCata. And so, we've had a very good relationship with the entire SuriCata team ever since way back in those days. So, and again, I want to make sure that I emphasize how thankful we are for all of your hard work on SuriCata. Way back to 2010 and to today, we have this brand new SuriCata 4.1 that we're really excited about that I'll talk a little bit later. So in 2011, we kind of moved from being kind of a live CD that you could just kind of play with to something that's more supportable, more deployable, and we can actually do in-place upgrades. And so we started putting on our big boy pants and being more enterprisey and doing things the right way. And as more and more folks were deploying our software to larger and larger networks, of course, they needed to handle more and more traffic. And so that really caused us to start looking at things like PF rings so that we could really do some higher throughput situations. So that came out in 2012, and that really helped us to get to the next level in terms of network visibility. So a few years go by, and we just continue to iterate and make progress and continue to keep each of these packages updated as the years go on. And of course, as I mentioned just a minute ago, SuriCata 4.1, really excited about that. So we packaged it, I think, within a week of it being released, and we were able to release that to our folks, and really excited about all the new capabilities that gives us. And so, you know, today we have folks that download Security Onion, and within 10 or 15 minutes, they're firing up SuriCata, they're watching their network traffic, they're generating IDS alerts, and they're starting to do that incident response process. So that's a very brief history of Security Onion. So in terms of the platform itself, you can download our ISO image. And we're currently sitting at, I think, about 697,000 downloads. So if everybody in this room could just go ahead and set up a wget in a for loop and just start downloading that ISO image to help us reach that 700,000, that'd be great. So if you don't want to download our ISO image, that's cool. All of our software is available in standard Ubuntu packages, so you can take Ubuntu 16.04, whatever flavor you want. You can add our PPA and install our packages, and you can be up and running in a few minutes that way. And so at the end of it, once you've installed our ISO or our PPA, whatever the case may be, you're going to have not only SuriCata and these other great kind of network tool sets, but you're also going to have the entire Elastic stack to collect all of those logs to allow you to slice and dice. So we've got Logstash parsers built in for all kinds of logs so that all of those logs are being recognized, they're being normalized, they're being augmented and decorated, and then we give you somewhere around 30 pre-built dashboards in Cabana to help you slice and dice all of this data. Again, not just network data, but host-based data as well. So I mentioned before that we kind of tried to move from the notion of network security monitoring to more enterprise security monitoring, to say that, hey, that network visibility is great, but we really would like to have some endpoint telemetry as well. And so, you know, for example, if I'm working an incident and I see that there's some interesting looking network traffic, well, I might be interested in, okay, from that host, what was the actual process that generated that traffic? What more can I learn about that particular process or the binary itself, or can I get its hash? Can I do some other things with it? And then furthermore, what else did that process actually do on the box, right? So that process generated some network traffic. Maybe it generated some HTTP connections or some connections out to a command and control channel, whatever the case may be. But in addition to that network stuff, it probably did some stuff on the host itself. Right? It probably created some files. It probably created some registry entries if we're talking about a Windows box. Maybe in terms of registry entries, maybe it created a persistence mechanism. Right? So we'd really like to get visibility into what's actually happening inside of those hosts. So we've got a few options that we integrate with really well today out of the box. And so because we have the Elastic stack, of course, we integrate with the Elastic Beats family of endpoint agents. So you can deploy those beats to your enterprise. You can start shipping those logs to Logstash on your Security Onion box. And we'll start consuming those logs and visualizing those inside of that Cabana Web Interface. In addition to that, we also, for a long time, have been using OSEC as a host intrusion detection system. Now, there's kind of a new more modern fork of OSEC called Wazoo that we recently migrated from OSEC to Wazoo to give us a lot more of these new modern capabilities. And we'll talk more about that in a minute. But in addition to that, you know, from a Windows perspective, Mark Rusinovich and his team at SysInternals, they create some really great utilities that give you some really good visibility into your Windows boxes, things like sysmon and auto runs. And so we've spent some time to make sure that we can ingest those logs, that we can parse them, and that we can present those to you and help you in your hunting expeditions using that material. And then finally, OS Query is a relatively modern tool, and it's getting a lot of traction in the endpoint space. A lot of folks are deploying it across their enterprises. So we have some kind of initial integration work there. We have more to come, and I'll talk more about that in a few minutes. So let's talk about Wazoo and sysmon and auto runs for a minute. So in terms of Wazoo, Wazoo is a cross-platform host intrusion detection system. So we have a Wazoo server included in Security Onion. You can then deploy Wazoo agents out to your enterprise, whether that's Windows boxes or Mac OS, Unix, Linux, FreeBSD, just about any place that has a compiler, you can compile this Wazoo agent, and it's going to give you a few things. So it's going to give you log collection. It's going to give you encrypted log transport. So when the agent sends its logs over to the Wazoo server, all of that's encrypted by default. You don't have to do anything extra special. It just happens. In addition to that log collection, it's also going to give you file integrity checking. So every few hours, it's going to be looking at the critical system files in the box, and if anything changes, it's going to notify you of that. The Wazoo agent also does some rootkit detection as well. And so the final thing to note here about kind of the relationship between the Wazoo agent and the Wazoo server is that the Wazoo agent is a very dumb agent. What do I mean by that? Well, I think we've all experienced those painful endpoint agents that use up way too much CPU and use up way too much RAM, and they end up bogging down your box. And that's simply not the case with Wazoo because it is a very dumb agent. It actually doesn't do any analysis in and of itself. It simply collects the information, ships that to the Wazoo server, and that's where all the analysis takes place. So, brief overview of what that installation process looks like. So the first thing that we would want to do if we've deployed Security Onion, we would want to run a command that we have called SOAllow, and that's going to poke a hole in the host space firewall to allow our Wazoo agent to connect to our Wazoo server. Once we've done that, then we can create an agent key on that Wazoo server and then export that agent key, and that's what's going to set up that encrypted communications channel so that the agent can send those logs totally encrypted over the network. Now, the Wazoo agent, in terms of Windows deployments, that's an MSI, so you can push that out doing a standard installation, or you can push it out with Active Directory or whatever other kinds of agents you have there. You would then import that agent key, and then your agent would be able to connect using that agent key, authenticating to the Wazoo server through that host-based firewall, and ultimately sending all of those logs, the telemetry from that endpoint. So there's a few steps there, and so of course the question you're asking is, well, that's a painful process if I want to do this across my enterprise. So you're in luck. This process can be automated. So for example, we had a customer a few years ago, and they wanted to deploy this across their fleet of 700 Windows servers. So we automated that process, and so they absolutely were able to push out the agent and all of the agent keys and everything necessary to get this encryption happening and the logs flowing. So that's Wazoo. Now let's talk about sysmon. As I mentioned before, sysmon is part of the SysInternals suite of utilities by Mark Rusinovich and his team at Microsoft. And it really gives you some really good comprehensive host logging. So you can log process creation, you can log when a process creates a network connection. I want to log that so that I can later then correlate, okay, this connection, what was the process that actually generated that network traffic? And it can do lots and lots of cool stuff regarding the file system, the registry, network connections, and things like that. Very, very powerful tool. Totally free. You don't have to pay a dime for it. You just download it from that address there. And then you install it very, very simply. It's not even a full setup program that you have to run next finish. You simply run sysmon-i-accept EULA, and you're installed. It's very, very simple. Now, this is where Taylor Swift comes into play. So, you can imagine Taylor Swift, for those of you that are fans, and even for those of you who aren't fans, she writes this great music, she does these great shows, she's traveling all the time, she's a very busy lady. But somehow, she still finds time, maybe on her tour bus, I don't know, but to write these great sysmon configs so that we can take advantage of that. From all of her experience of touring around the world, being a rock star, that gives her this great experience to provide sysmon configuration. So you can follow at Swift on Security on Twitter, and you can then go to the GitHub site. The GitHub repo for Swift on Security has this great sysmon config. It's already pre-built, it's already pre-configured, and it's been battle tested. It's been deployed in many, many organizations over the years, and it works quite well. Now, when you read about that, you'll read that it's to be considered a starting point. Obviously, you don't want to just deploy that and you're done with it. Obviously, just like anything else, you want to use that as a starting point. You want to tune that as time goes on. So once you've downloaded that sysmon config, you can then import that config using the -c option. So sysmon-c and the full path to the configuration file. So again, very, very simple. Sysmon, you download it, you install it with the -i. You then download your config file, you configure it with -c. Very, very simple stuff. The other tool that I mentioned from sysinternals is auto runs. And so auto runs will take a look at a Windows system and we'll look at all of those auto start extensibility points and look into the registry and show you all of those places where malware authors may be trying to establish those persistence mechanisms. So again, totally free tool. You can download it from Microsoft.com and then configure it to run on a periodic basis. Maybe you want to run on a daily basis or whatever the case may be. So a really brilliant guy in our community, Josh Brower, he developed what he calls Pertinax, which is kind of his integration project for ingesting auto runs logs and parsing them, normalizing them, and really making sense out of them from a visualization perspective. So we've taken all of his really great work, we've integrated it into Security Onion, so you get to benefit from this in an out-of-the-box experience. You don't have to do anything special, just ship those auto runs logs in and the sysmon logs as well, and we know what to do with it from there, and we'll give you some nice visualizations. So then, this is where it all kind of comes together, because we deploy Wazoo, we deploy sysmon, we deploy auto runs, and then we configure Wazoo to collect those logs from both sysmon and auto runs and transmit them to our Wazoo server. Right, so we just deploy these 3 small little pieces of software, we collect those logs, and then that's going to give us a whole lot more endpoint visibility across our entire enterprise. So let's talk about some use cases. So you can go and, if you've never used Security Onion before, you can go and download it today, and you can help us reach that 700,000 download mark. And you can deploy it in a small VM, so 8 gigabytes of RAM is really all you need to get up and running with Security Onion. And in 10 or 15 minutes, you can install it. You can replace some PCAPs, or you can use our relatively new tool called SO Import PCAP to import that PCAP file, preserving all the timestamps. And then you can bring in logs from your endpoints, and you can do that all within a single small little VM just for test purposes to get your feet wet with it. And then kind of as you get more comfortable with it and you're ready to deploy it to your enterprise, of course you can start off with kind of a standalone deployment. Just stand up a single Security Onion box. And then as your needs grow, both from a network perspective and from an endpoint perspective, maybe you start to grow that standalone deployment to a distributed deployment where you have a master server and you have multiple network sensors, and maybe on the back end you have multiple storage nodes as well. So we've really designed this deployment to be scalable kind of in both directions. So we can start putting out hundreds of network sensors and really scaling our back-end storage as well via storage nodes. So just in terms of scale, for example, we have one customer that they're over 600 sensors today with plans to go to 800. And we have a new platform that I'll talk more about later, and we hope to scale that even further to be able to support really, really large enterprises. So I talked a little bit about this kind of this small forensics VM and how you can download Security Onion today and get a feel for it. So let's actually use that as our case study. So we'll actually take a look at a real-world data breach, and we'll take a look at kind of the network artifacts, and then we'll also take a look at some host-based artifacts as well. And we'll see how we can very simply tie these things together in one interface using all the data that we're collecting. All right. Can everybody see that okay? All right. So this is our Cabana Web Interface, and this is showing all of the logs that we've collected so far. And so we kind of have this default dashboard that you come into when you first log into Cabana. But what I'm actually showing you here is what we call our indicator dashboard. And so what we anticipate folks doing is kind of starting on the default dashboard and finding some interesting indicator, finding whether it's an IP address or something else of interest. And we've tried to create hyperlinks just about anywhere within the interface that we can to allow you to then pivot more easily to drill down into that information. So for example, you might start on that default dashboard and you might see that there's some interesting Suricata alerts for some network traffic coming from this particular IP address, 172.16.150.20. And so when you would click on that particular IP address, it would take you to this indicator dashboard, essentially saying, hey, show me everything you know about this particular IP address. And as you can see, we have lots of different data types here, not just our IDS alerts, not just our network metadata logs, but we've also got our sysmon logs and our autoruns logs. So really being able to pull both the network and the host together in one dashboard and really giving us that ability to slice and dice and drill down as much as we want to. So let's actually kind of work through this kind of step by step. So what kind of kicked us off in this investigation was the fact that we had some Suricata alerts for, in this case, a suspicious-looking Windows EXE, right? So whenever I see an interesting-looking Windows EXE, I definitely want to investigate that. And because we have full packet capture, we can actually drill all the way down into that particular TCP stream. We can see that EXE in its entirety. We can actually reconstruct that file from the PCAP if we want to. So I'll just very quickly pivot over to here. And so this is the actual TCP stream where that file was transferred. And so because we have the full packet capture, we not only see the GET request from the workstation and the web server's response, of course we see the telltale MZ file header of that Windows EXE. But because this is a Windows EXE, I might want to look through here a little bit further and look for any interesting indicators that might pop out, things for which I may not have any IDS alerts already pre-written for. So let's just start looking through here. And we see things like a connect string. That's interesting. I didn't have any IDS alerts for that. I might scroll a little bit further, and I might see some more interesting stuff here. All right, so for example, I see a hard-coded IP address. So in terms of my investigation, I might then want to say, well, if there's a Windows EXE with a hard-coded IP address, if the user downloaded that EXE and executed it, I might expect to see traffic going to that IP. So I could then test to see if the user executed it by looking and seeing if I had traffic to that IP address. And we'll take a look at that in just a minute. But in addition to that, we do see some other interesting things here in terms of service host. So we see that, and we might want to make a mental note of that and kind of come back to that later, because as I was mentioning before, we're really interested in if this exe executes on this user's machine, it might generate some network traffic, but it might also do some stuff on the host itself, right? It might be doing something relating to this particular exe name, so we might want to try to tie that back and correlate it. So that's definitely very interesting. The other thing that we see here, which is interesting to me, is this very special Windows key here, the run key, which is used, of course, for persistence mechanism, right? So if an attacker can get you to run this exe on your computer, well, then it's going to write to the run key, and the next time that you restart your computer, it's going to restart that malicious process again. And so now we kind of have evidence of this persistence mechanism. So again, we might be interested in looking at that endpoint for more information about this particular run key. Was it actually modified? How was it modified? What is it actually pointing to? And can we use those indicators to then search across the rest of our enterprise to see if those indicators might be popping up on any other endpoints? Right? So really providing this holistic view of what's happening on our enterprise and giving us the ability to do really holistic investigations. So that was kind of our first initial hit. So we pivoted from our IDS alert to our full TCP stream. We saw some interesting indicators that'll definitely be interesting from a host-based perspective when we get there in just a moment. But let me kind of finish running down kind of the network perspective, and you'll see that we can get a lot of intelligence just by looking at the network piece, but then we'll kind of flip over to the endpoint piece, and we'll fill in a couple more gaps there. So as we work our way through this investigation, we saw that hard-coded IP address to that 221. And so if I were to then use my Cabana Web Interface to search for connections to that IP, I would see that yes, indeed, I did actually have a connection to that IP address. Now, when I pivot to that full packet capture, I see that it's totally encrypted traffic. So at that point, I have somewhat of a blind spot. I may not be able to decrypt that. I may not be able to make any sense of it whatsoever. But if nothing else, I can sort of get the sense that this is a command and control channel, that this machine has actually checked in to the attacker's command and control server. And as we scroll through here, kind of noticing our color coding with source being highlighted in blue and destination being highlighted in red, we can definitely see that there's a good amount of traffic, number one, and number two, that there's back and forth. There's sort of this call and response in terms of seeing a little bit of traffic coming from source and a little bit coming from destination. This kind of gives me the sense that I might be able to infer this is maybe like an interactive shell session, right? So if you're issuing commands over a command and control channel and you're typing in dir and you're getting a directory listing, it might look something like that from a network perspective, right? We don't know that for sure. We're just kind of wagering guesses at this point. But if nothing else, we've kind of confirmed that that IDS alert was definitely very interesting because it was an interesting EXE, and it's now produced some follow-on network traffic to this attacker's IP address. So if I then want to take the investigation to the next level, I would start to say, well, what other connections have I seen from this particular endpoint? And that's when I would, from my original dashboard, I would see that I had some FTP traffic. And as we all know, attackers love to be able to exfiltrate data over FTP. So let's just take a look and see what that's all about. So here we see the attacker telling this compromised endpoint, hey, I want you to log into my evil FTP server, and I want you to upload these two files, 1.txt and 2.txt. And so at this point, we know that, okay, attacker is issuing commands. They definitely have full remote control of this particular Windows endpoint, and they've now exfiltrated some data. We don't really know what that data is because that particular TCP stream ends right there. All right, so we have to kind of think back to the way that FTP works. You've got a control channel, you've got a data channel. So now let's flip over to our data channel and let's see what was actually transferred. Now the plot thickens, because now we're seeing, at the beginning of this, evidence of gsec dump. That's a utility used to dump Windows password hashes, right? So an attacker might be wanting to take our password hashes offline and brute force them with something like John the Ripper, or they might just want to use the hashes natively using a pass the hash attack. Now, in this case, if I were to look at this output, I'm not actually seeing Windows password hashes here. And this is a little bit of a mystery because what I'm really seeing here is kind of the help output for the command, right? Kind of like if you were to type gsec dump -help or something like that. But what might be happening here is maybe we're seeing evidence of an attacker actually being in a hurry or being clumsy or being lazy. And just like the rest of us, maybe fat fingering his command options and maybe messing it up, and gsec dump says, nope, you're an idiot. Those aren't the correct options. Here's the correct options. And so instead of exfiltrating the actual password hashes, in this case, the attacker exfiltrated the help output, right? So it's kind of fun when you can kind of laugh at the attackers because they're just human just like we are, right? But if we remember, there was one other file, and so we might want to go and investigate that because that might be a little bit more serious. But before we go there, let's kind of think about the fact that we might at first be tempted to say, well, because there weren't really password hashes here, we're not really concerned about it. But one of the key nuances to pick up in this particular incident is that gsec dump is not included by default in Windows, right? So if we're seeing evidence of it executing, then that's also kind of giving us an inference that the attacker was able to transfer his tools to that particular endpoint, right? So again, it's all about collecting the data and being able to use that data to create inferences and try to reconstruct the scene of the crime as things are going along. So now let's take a look at kind of our final TCP stream from this particular compromised Windows endpoint. And as we can see, this is actually a RAR file that's being transferred over this FTP connection. And because it's a password-protected RAR file, we can't actually see the contents. We can't actually see what's happening inside. So at this point, we would go to what I kind of mentioned earlier, and that's the fact that because we have full packet capture, we can actually reconstruct files right out of that full PCAP. So let me download that PCAP, and I'll open it up in Wireshark. So then I can do a good old follow TCP stream. I can change this to raw. I can save as, and we'll just call this out.rar. So now if I go to my downloads folder, I've got this out.rar that I've been able to reconstruct from my full packet capture. And when I double click on it, it prompts me for password. Now, we might be able to kind of look back at some of our other TCP streams that we looked at for indicators like the username and password that he used to log into the FTP server. He might be doing some password reuse there. We might be able to figure out what's going on from that. We might be able to make some other guesses based on some other intelligence that we can gather from this traffic. But let's suppose that we didn't actually succeed in gathering intel from the other traffic. We might then kind of take the aspect of, well, if the attacker was going to take my Windows password hashes and run them through John the Ripper to crack them, well, maybe we could do the same thing, right? We could actually use John the Ripper to crack this RAR file. And you can actually do that. I won't take the time to do that, but when you do, you can crack the password. And now you can actually see the files that were in that RAR file that have now walked out the door, that have now left our network and were exfiltrated to that attacker's FTP server. So that's really cool, and that's an amazing amount of visibility that we can gather just from the network perspective. But as I mentioned before, there's other intelligence to be gleaned from the endpoint perspective as well. And in particular, when I go back to that very first TCP stream, we saw things like servicehost.exe, and we saw things like that persistence mechanism, that run registry key. So now let's take a look at how we might get some visibility into that. So we have another dashboard that's specifically built for our Wazoo host intrusion detection system alerts. And in this case, what you can see is I actually do have an alert coming from Sysmon for a suspicious process named servicehost.exe, right? And so what's happening here is that let's suppose that the user ran this particular exe on their host, and maybe it started another process, and as Sysmon is running on that host and it's logging those processes and interrogating those processes, it sees something strange, something anomalous about that process that doesn't quite match up with the standard legitimate Windows service host.exe. And so Sysmon logs that, and then we have rules on the back end for the Wazoo server to interpret those Sysmon logs and then ultimately generate this particular Wazoo alert. And so now this becomes really a kind of a high fidelity alert that says, there is a legitimate Windows service host, but when you see this particular alert, that means something's not quite right. So that's some really good visibility for that particular aspect of this incident. In addition to that particular Sysmon log, we have a separate Sysmon dashboard that can take all of your Sysmon logs, provide you visualizations, allow you to slice and dice those Sysmon logs. And so, for example, here's just one of those Sysmon logs. And the really nice thing about this, and I kind of mentioned this earlier, was, if you see that there's network traffic coming from a host, what you might want to be able to do is kind of correlate that back to the actual process that generated that traffic. And using Sysmon, we can actually do that. So in this case, what we're seeing is this is a Sysmon log for a particular network connection, and it's actually able to tell us the process which generated that traffic. So in this case, all I did was I fired up Firefox, and I generated some traffic. Sysmon logged that, so now I can actually kind of work backwards from that network piece back to the host piece and really pin that down to a particular process. So, this helps in two ways. Number one, in this case, this was Firefox, so I might say, well, this might be legitimate, a legitimate connection, because that's something that you always have to do when you're working your investigations is sifting through that needle stack, right, to find that one needle that you're looking for and figuring out what's the legitimate traffic, what's the suspicious traffic. By correlating back to the originating process, that can help us sort of sift through that pile. And then finally, we do have a separate dashboard for auto runs data. And again, that's the utility that's looking for persistence mechanisms. So here you can kind of see this long thing, that's the actual raw auto runs log itself. And if I zoom in here, this will help us to see that that persistence mechanism that we saw in that Windows exe of that run key is actually pointing to this servicehost.exe. So again, being able to kind of tie all of these indicators together from a host-based perspective really helps us to paint a more complete picture of what happened in this particular investigation. That pretty cool? You like that? All right, so that was our case study. I want to switch gears a little bit and talk about our new platform that we just announced at Security Onion Conference a couple of weeks ago. And this is called Hybrid Hunter. So as I mentioned earlier in the presentation, our traditional Security Onion distribution is based on Ubuntu. But one of the pieces of feedback that we've gotten over and over and over again is to support CentOS and Red Hat. And so I'm very excited to announce that we're now going to be doing that. We've built a brand new platform that instead of using Ubuntu packages, everything is Docker-based. So you can take these Docker images, we manage those using Salt, and you can now deploy those on top of Ubuntu, on top of CentOS, on top of Red Hat. And so we just released kind of the initial tech preview for that new platform called Hybrid Hunter. And one of the other big changes that we're doing there, I mentioned earlier in the talk that way back in 2012, we compiled Suricata with pfRing. We're now moving to AF Packet, which makes it a whole lot easier to support this new Docker platform, and will give us much better network performance and more ability to tweak that performance of those network sniffing engines. So that's Hybrid Hunter, and just this week we released Hybrid Hunter 1.0.3. And that does include Suricata 4.1, so as soon as that was released, we wanted to make sure that we put a new Hybrid Hunter release out that contained Suricata 4.1. And one of the new features there is it does ask you if you want to enable all of that new protocol logging that's included in Suricata 4.1. And so we're really excited about the future of having all of that protocol metadata coming from Suricata and providing that to assist in our investigations. So that's our new Hybrid Hunter release. You can go to our blog, blog.securityonion.net, and there's a blog post that talks briefly about Hybrid Hunter 1.0.3 and gives you instructions on how to actually download it and play with it. Now, as a part of this new platform, we do have some more endpoint integration coming. I mentioned very briefly earlier that we have some initial integration with OS Query, and that came with our move to Wazoo, because Wazoo has some initial OS Query integration. We've got a whole lot more OS Query integration coming. I mentioned Josh Brower before, and he just presented at our Security Onion conference a couple of weeks ago about his OS Query integration that he's been working on, and so we're now working with him to bring all of his integration work for OS Query into our new Hybrid Hunter platform. So we're hoping to have that out within the next couple of months. So again, really providing the best of breed open source utilities for not just network visibility, but endpoint visibility as well, so that folks can have this great set of tools and really help to rebalance that equation. And really give themselves the advantage against the attackers that are breaking into our networks. So how do you get Security Onion? You can go to securityonion.net. You can download our traditional platform, or if you want to play with the new Hybrid Hunter, you can go to blog.securityonion.net and click on the link there from that first blog post. And we'd love to hear from you. So if you try either of those platforms and you have feedback, we'd love to hear from you.